The moon is the nearest heavenly body from the earth. Since ancient time, storytellers, poets, and musicians had created a number of great works, such as this song. Do you know someone had indirectly measured the surface temperature of the moon during the 1890s, almost a century before American astronauts landed on the moon? This guy. His name is Samuel Langley, and this is their monumental book entitled The Temperature of the Moon. Very is his co-investigator. In this book, the prediction is 353 Kelvin, although their early estimate is 318 Kelvin, which is very close to the summer temperature on the Earth. But how did they do that? Is their method reliable? We will find them out today. This is the instrument he built by himself called spectro-Bolometer. At its heart, can you see, is the Rock-salt Prism, similar to what Issac Newton used for separating colors from the visible light. Obviously, it is essential to ensure that the prism is transparent for infrared rays. Because infrared rays are invisible, therefore, thermal effect is converted into electrical current for such measurement. Here is a typical observed spectrum, which gives the transmitted infrared ray measured on the ground of Earth, which is, of course, not the thermal radiation spectra of the moon that could be observed above the atmosphere. The horizontal axis is a refraction angle in degree caused by the triangle prism, which can be converted into wavelengths by using these tables they provided. The deeper these values are, the stronger the atmospheric absorption would be, similar to what you see in the transmission spectra by using a modern commercial infrared spectrometer. Here, the dashed bell-shaped envelope was inferred by Langley and Very based on their measurements. It is this unsymmetrical bell-shaped curve that was used by them to determine the surface temperature of the moon. For our quantitative analysis, I have transformed the fractional angle into wave numbers, as shown in decimal file. The solid curve is a transmitted thermal radiation of the moon. The dashed curve is their proposed thermal radiation spectra of the moon. The area between the two curves represents the atmospheric absorption. Notice the maximum absorption occurs partially inside the so-called atmospheric window. This seems strange because, according to the consensus, the atmospheric absorption should be a minimum inside the atmospheric window rather than maximum. Besides, almost no absorption of carbonic acid was observed around 15 micron, as shown by this green band. Surprising? In fact, Arrhenius used Langley's data to build his atmospheric model in 1896. Did he know that? I don't think so, because the 15 micron absorption band was not observed until 1899. Anyway, let's use a Planck function to see if we can fit the dashed curve, namely the proposed thermal emission spectra of the moon by Langley and Very. Here is a Planck function B, and this is a temperature adjustment. Now let's change the temperature. As you can see, part of the dashed curve can be fitted by Planck function around 500 Kelvin, much higher than their reported 394 Kelvin. Besides, it seems impossible, as you can see, to fit the non-short wavelength tail by using the Planck function. What does it mean? It implies that the moon temperature reported by Langley and Very is not very reliable. In passing, the temperature of the moon at the Apollo 11 landing site was 363 Kelvin. But based on the shadows of the astronauts in this photo, the location is very far from equator, where the temperature could be noticeably higher at noon. Of course, one can now repeat this measurement over a century ago by either a purple prism or a modified commercial FT infrared spectrometer. Meanwhile, it is technically feasible to measure the lunar thermal emission spectra directly from a satellite or from the International Space Station. Since 1970, NASA has sent a number of the satellites with FT infrared spectrometer on board called IRIS to measure planetary thermal radiation, including Venus, Earth, and Mars. But why did nobody bother to record a thermal emission spectra of the moon in space? By the way, due to his fame, Langley received a large sum of financial support to develop flying machines, nowadays called aeroplanes. But his team was beaten by Wright brothers in 1903. Thank you for watching. If you enjoy this talk, please like, subscribe, and keep your little bell activated. See you next time. The blue curve is theoretically calculated, which is to be explained soon. As you can see, the coordinates of the three planets, namely Mars, Earth, and Venus, can be quantitatively predicted. Is that beautiful? I remember my teacher said Newton was merely puzzled by the first push because he believed that his mechanics to fix the fundamental problems of the standard model, isn't it? Let's remember C.G. Ozawa, my favorite conductor, who created joy. Arrhenius claims CO2 is the chief absorbent on his paper, page 260, without any direct experimental evidence, such as this one demonstrated with this Newton's cradle. As you can see, something must have been transferred among the metal balls. But what is this something?